around, कब start किया था हमने, है ना? तो at the end of April we started solution chapter, ठीक है? So we have been slow because like I think on every week or so, or I would say that rather like in every class there is a few new students, so we have been a bit slow, but still we got to cover a large portion in solution chapters. Okay, what is going on in your school, Nida?
We finished the chapter.
You finished the chapter. पढ़ा है आपने वहां से स्कूल से या फिर नहीं पढ़ पाए आप?
जी
पढ़ा है आपने ना?
हाँ
ठीक है, तो सोल्यूशन में आपको जैसे पता होगा कंसंट्रेशन टर्म is the initial topic, जहाँ पे you have majority, the main thing that is there is mass percentage, molality, molality and mole fraction, है ना? These things are the major points in concentration terms. After that we have a topic which is known as solubility. Then we have insolubility. First of all, solubility का definition, saturated, unsaturated, then dissolution and crystallization, all of these things are the solubility. Then we have solid in liquid, है ना? And what are the factors affecting the solubility of solid in liquid? Then we study about gas and liquid. और गैस इन लिक्विड में क्या रहता है, एक इंपॉर्टेंट जो टॉपिक है, दैट इज हेनरीज लॉ, दैट इज द इफेक्ट ऑफ प्रेशर ऑन द सॉल्युबिलिटी ऑफ गैस इन लिक्विड, है ना? हेनरीज लॉ. ओके, देन वी हैव अ नेक्स्ट टॉपिक दैट इज वेपर प्रेशर. उसके बाद आएगा आपका रॉल्स लॉ. तो ये वेपर प्रेशर तक हम लोगों ने पढ़ा लिया, ठीक है? वेपर प्रेशर तक हम लोगों ने पढ़ लिया. रॉल्स लॉ है, एंड आफ्टर दैट रॉल्स लॉ वी हैव colligative property. So in colligative property you have four things. You have RLVP, relative lowering of vapor pressure, right? Then you have elevation in boiling point, then you have depression in freezing point, then you have osmotic pressure, and उसके बाद आखिरी में एक टॉपिक आता है abnormal mass, ठीक है? So these things are there, colligative property, and then today we will be learning about Raoult's law. Okay, today we will be learning about Raoult's law. Okay, Atif is asking one question. Yes, Atif, I will explain this question. ये तो हेनरीज लॉ का है ना? हाँ, हेनरीज लॉ का, ठीक है. Raoult's law, and after that here also we have some topics such as ideal, non-ideal, okay, ideal, non-ideal solution, azeotrope. Okay, so all of these topics are there in Raoult's law. So we'll be studying about Raoult's law today. उससे पहले there is a question in assignment that I have to discuss, ठीक है? So let me get that question. That is a good question, by the way. I mean good in the sense that it is a bit different question that you have to look into the units of case that is given. उसके बाद आप कर पाइएगा संडे के दिन, ठीक है? सैटरडे के दिन का है आई थिंक ये, फिर हेनरीज लॉ ना, सैटरडे में सी. आतिफ ने सिर्फ पूछा, यानी कि बाकी लोग, कृष्णा आपने किया था लास्ट सैटरडे का?
Yes, I have done that solubility of gases and liquids, right, sir?
सॉलिबिलिटी ऑफ गैसेस इन लिक्विड, आई थिंक, हाँ यही है हेनरीज लॉ वाला. ये सवाल हुआ आपसे, द फर्स्ट क्वेश्चन?
No, sir, I am having that doubt itself. I wanted to ask you.
अच्छा, ठीक है. So the question here is saying the concentration of nitrogen should be present in a glass of water. What concentration they are asking essentially? What concentration of nitrogen should be present in a glass of water at room temperature? Assume temperature of 25 degrees Celsius and total pressure of 1 atmosphere, and mole fraction of nitrogen in air is 0.78. ठीक है, 0.78. ठीक है. Now this is an important question. Why? First of all, they are saying that we have here there is some kind of solvent in which we have added nitrogen. Okay, here we have added nitrogen. Okay, what is the concentration of nitrogen should be present in the glass of water at room temperature? Room temperature में है, in that we have added nitrogen. Assume the temperature of 25 degrees Celsius and total pressure. Now the total pressure that it is present, total pressure कितना होता है? If you don't have anything, it is equal to 1 atm, right? Now in this 1 atm there will be pressure due to nitrogen, plus there will be pressure due to oxygen, plus there will be pressure due to carbon dioxide and other gases. Yes or no? Please tell me. Correct hai?
Yes, sir.
Right? Now, so we have to first of all see what is the pressure due to nitrogen. है ना? What is the pressure due to nitrogen? Because if you are dissolving something here, if you are dissolving some gas here, then it will be liberating out nitrogen. है ना? उसी का हमको देखना है कि what is the pressure due to nitrogen here? What is the pressure due to nitrogen? Now see, they are seeing the total pressure at the total atmosphere. Sorry, the total pressure is how much? 1 atm. So P total is equal to P total for what? The complete gases N2, O2, CO2 सबको मिला के कितना है? P total is equal to 1 atm, and the mole fraction of N2, it is equal to how much? 0.78. So now according to Dalton's law of partial pressure, you should know that the partial pressure of any gas is equal to what? Its mole fraction multiplied by the total pressure. कुछ याद आया आप लोगों को? Yes or no? Please tell me.
Yes, sir.
Okay, so we'll get the partial pressure due to nitrogen is equal to how much? 0.78 into 1 atm. तो कितना आ जाएगा? 0.78 atm. ठीक है, कोई दिक्कत यहाँ तक? Any problem till here?
No, sir.
No, na? Okay, fine. Now the next thing that they have given is the KH of nitrogen is 8.42 into 10 to the minus 17. Now you see the unit that they have provided here. Okay, see the unit that they have provided here. So they are saying now KH is equal to 8.42 into 10 to the power minus 17 m divided by mm of Hg. If you look at the units, so they are saying that KH is equal to how much? Concentration upon pressure. सही है? Yes or no? Please tell me.
Yes, sir.
Okay. Now they're saying KH is equal to this much. So now the unit is giving you the formula. The unit is giving you the formula. As the unit is given, the same way you will use the formula. What they have given, KH is equal to concentration upon pressure. KH is equal to concentration upon pressure. So from the question itself, we know what is the KH, right? So we know the KH. What is the pressure due to nitrogen? We have just calculated 0.78, and then you just have concentration term, that is a variable that you can find out, right? You have concentration which is unknown, and it is now linear equation in one variable. So what is KH? It is equal to 8.42 into 10 to the power minus 17, right? This will be equal to concentration, and that will be in terms of moles per liter divided by pressure. What is pressure given here? 0.78 atm. 0.78 atm, है ना? अच्छा, now there is one more thing that is एक दिक्कत यहाँ पे आपके पास ये होगा, ठीक है, उसको हम लोग कल ये कर लेते हैं. 1 atm is equal to 760 mmHg. Okay, 760 mm of Hg. Now this 8.42 into 10 to the power minus 17, it is given in terms of what? It is given in terms of mmHg. Okay, this is given in terms of mmHg. Now you have to calculate concentration. Concentration, it will be equal to how much? Concentration, अच्छा ये तो आपको दिया molarity upon mmHg ना. So concentration will be equal to 8.42 into 10 to the power minus 17 into 0.78 into 760 mmHg. यहाँ तक समझ में आया सबको? 8.42 into 0.7278 into ये 760 mmHg क्यों लिखा हमने? All of you got this ना? Yes or no? Please tell me.
Yes, sir.
Yes, sir.
है ना? Because 1 atm is equal to 760. So atm को remove किया, atm की जगह mm of Hg, but 760 के साथ, ठीक है? Now this is equal to this much divided by, यहाँ पे आपके पास molarity होगा, concentration. एक सेकंड चाहिए, थोड़ा सा let me just take some space, है ना? यहाँ पे units में आप लोग को थोड़ा दिक्कत होगा, नीचे ही लिख लेते हैं. So we have here, KH is 8.42 8.42 into 10 to the power minus 70 मोलारिटी अपॉन mmHg। उसके बाद हमने कंसंट्रेशन जो भी सॉरी यहाँ पे प्रेशर जो मल्टीप्लाई किया वो कितना है 0.78 इंटू 760 mmHg। ये जो भी आंसर आएगा दिस विल बी इक्वल टू कंसंट्रेशन। ठीक है, सो वी विल बी कैंसलिंग mmHg हियर और आपके पास जो आंसर आएगा दैट विल बी इक्वल टू 8.42 इंटू 0.78 इंटू 760 इंटू 10 to the power minus 17 moles per liter. This will be the concentration. Okay, so this will be the concentration of N2 in water at room temperature. ठीक है, so whatever water you are drinking ना, that will have this much amount of nitrogen gas in it, because nitrogen gas आपके air में है ना, if it is traveling here and there, it will be striking inside the water molecule that you are drinking. So please calculate this. समझ में आ गया ना आतिफ, कृष्णा, सबको?
Yes sir.
ठीक है, तो यहां तक लिख लीजिए, बाद में कैलकुलेट कर लीजिएगा। ठीक है, दिस इज इंपॉर्टेंट दैट द यूनिट इज गिविंग यू द फॉर्मूला। ठीक है, यूनिट इज गिविंग यू द फॉर्मूला। अगर आप सोचते हैं कि हम इस तरह से करते हैं कि प्रेशर इज इक्वल टू KH इंटू काइब, तब तो बहुत दिक्कत हो जाती है आपको। ठीक है, सो यू विल गो बिकॉज यूनिट यहाँ पे बहुत इंपॉर्टेंट है, मोलारिटी अपॉन mmHg है, तो वहीं से लेके हम इसको डिराइव करेंगे जो भी आंसर आ रहा है हमारा। डन ना ऑल ऑफ यू?
Yes, sir.
चलिए ठीक है, तो विल मूव फॉरवर्ड नाउ। निदा, आप अगर आपको समझ में नहीं आया तो बताइएगा निदा। ठीक है,
जी।
now the topic is Raoult's law. The topic is Raoult's law, but let us understand Raoult's law before writing whatever the definition of Raoult's law is there. ठीक है, so we are taking simple cases in which we have, let us suppose there is some water here, okay, and similarly there is some other solvent. Let us take the red color. Okay, so Nida, Kulsum, Mansi, you all will answer me. Okay, you all will answer me. So if we have water here, then the water, some of the water, it will evaporate, right? Some of the water will evaporate, है ना? And there will be some water vapor just above the water liquid. Yes or no? Please tell me. Is that correct? Yes or no?
Yes.
Yes. Kulsum, Nida.
Yes.
Yes. Okay. Now these are water vapors, and since these are water vapors, they will apply some pressure. They will apply some pressure because these are gases, and gases, they have pressure. One of the characteristics for gas is that they should have some pressure. Now for this, what I will say, this is pure water. That is why its pressure will be equal to, let's say this is A, it will be equal to P naught of A. P naught of A means the vapor pressure of pure A, vapor pressure of liquid that is pure A. If you have only A liquid, that means in that case you will have P naught A. Similarly, this red one also will have some kind of vapors, and this will be equal to P naught B. We have two liquids individually. If I see them, then if we have only A, the vapor pressure that will be created by A will be equal to P naught A, and similarly for B it will be P naught B. And if we add these two and we mix these two things, then we will get container. Let us say A is our solvent which is in maximum known, and there is also red here. Okay, so if I look at the vapor here just above the solution, there will be some red particles obviously, because the red one will also be getting evaporated, and similarly you will find some blue vapor also. Is that clear? Yes or no? Please tell me.
Yes, sir.
Yes.
Yes sir.
Okay, now if we calculate the total pressure, now total pressure is what? P total. This will be equal to how much? This will be equal to the pressure due to A, whatever the partial pressure is due to A, plus the pressure that is there due to B. Yes or no? Please tell me. Is that clear?
Yes, sir.
All of you? I know. Now, if I write like this, whatever the pressure is due to A, it is directly proportional to the mole fraction of A. That means if there will be more amount, if the amount of A is more, then the pressure due to A will also be more. Yes or no? If the amount of A in solution
Yes,
is
sir.
more, then the pressure due to A will also be more. Yes or no? Hamza, Heba, Kulsum, Mansi. Yes? All of you agree
Yes,
with
sir.
this? Okay,
Yes, sir.
fine.
Yes, sir.
Now, in order to remove the proportionality sign, what I will write? PA is equal to some K constant into chi A. Yes or no? Tell me.
Yes, sir.
Okay. Now, if I say add chi A is equal to 1, okay, that means chi is equal to 1. That means we only have the liquid A. There is no liquid B. है ना? Pure A है. Correct? If chi is equal to 1, then we have only one liquid, that is 8. Is that right? Yes or no? Krishna, Hamza, Heba,
Yes,
Akshay?
sir.
Yes? Okay. All of you, Mansi, Nida, बताइए कोई दिक्कत नहीं ना यहाँ तक?
Yes, sir.
Okay, chi A. Now add, if you have pure A, then the pressure due to A, it will be equal to how much? P naught A. है ना? PA will be equal to P naught A because only you have in the solution, there is no B, you have pure A, and hence you can write K will be also this PA is equal to what? P naught A, and that will be equal to K. Hence we can say that K is equal to P naught A, and we can write so the partial pressure due to A will be equal to the pressure of A when it is pure multiplied by the mole fraction of A. Now, is this statement clear with everyone? Yes or no? Please tell me.
Yes, sir.
Yes, sir.
All of you?
Yes, sir.
Yes, sir.
Okay, fine. We have just started, okay, Aisha, but you are very late. हमने सवाल एक discuss किया था, उसके बाद we have started now. Okay, Aisha?
Yes, sir. Actually, I just came right now from Jeddah.
From?
Actually, sir, I was in Jeddah. I came
अच्छा,
today
Jeddah में थे.
only.
अच्छा, अच्छा, okay. Now, all of you will write the topic, that is Raoult's law. All of you write the topic, Raoult's law. Now, what is the statement of Raoult's law? What does Raoult's law states? Please write with me. The partial pressure, or wait a second, for a solution of volatile liquids, volatile liquid, the partial pressure wait a second, ऐसे लिखे the partial vapor pressure of each component is directly proportional to its mole fraction. ठीक है? Now, if I write this down mathematically, that means if I have a component A, liquid A, its vapor pressure will be equal to PA. है ना? Its partial vapor pressure will be equal to PA, which is directly proportional to chi A, right? And PA will be equal to some constant K times chi A. And we know that at chi A, when it is equal to 1, then we can write PA is equal to P naught A, and hence K will also be equal to P naught A. है ना? So what is P naught A? The vapor pressure of pure A. Vapor pressure of pure A. So partial vapor pressure of A, it will be equal to the vapor pressure of pure A multiplied by the mole fraction of A that is present in the solution. And if I have two solution, we can write for a solution with liquid A and B. If we have a solution with liquid A and B, then the total pressure that will be present, the total vapor pressure will be the pressure due to A plus the pressure due to B. That means partial pressure of A plus the partial pressure of B. Now PA is equal to what? PA is equal to P naught A times chi A plus P naught B times chi B. Okay, P naught B times chi B. This is what P total. Now we also know that as chi A plus chi B is equal to 1, है ना? So we can write what? We can write chi A is equal to 1 minus chi B. And this will give me P naught A times 1 minus chi B plus P naught B times chi B. Okay. Now, if I want to expand this, this will be equal to P naught A minus P naught A chi B plus P naught B chi B. P naught A plus, now what we will do, we will take P naught B because it is plus minus P naught A and chi B as common. Chi B as common. Now this equation is very important. यहाँ पे P naught A होगा. This will be P naught A. Okay, this is P total. This is P total. Please write this down. This equation is very important. इसको लिखिए फिर I will tell you why this important, why this equation is completely very important. How many of you are in contact with your juniors? Raise your hand now. How many of you are in contact with your juniors? जो अभी 10 दिए हैं. कोई नहीं. Aisha. Who else? No one. Okay. So if you know any juniors and if you want to recommend Learnivio or any other classes ना, उनसे please कहिएगा 11th में जो लोग भी science ले रहे हैं, if they are taking science, they should start their coaching as early as possible, है ना? I think a few days ago their 10th board it ended, so they should start their coaching as soon as possible. There is no garmi chutti for 11th standard, okay?
Sure, sir.
If you have any cousins वगैरह या फिर दूर का भी कोई रिश्तेदार है ना, ऐसी रैंडमली आप उनको मैसेज करके बोल दो भैया कोचिंग ज्वाइन कर लो. नहीं, unless and until they read in a very good school, जहाँ पे स्कूल में भी पढ़ने से काम चल जाता है तो ठीक है. Otherwise, one should join some tuition or coaching. चलिए, everyone done? Yes or no? Please tell me.
Yes, sir.
Yes, all
Yes,
of you.
sir.
Mansi, Nida.
खोलिए ना सर फोड़ देंगे वो.
देख रहे हैं ना आप लोग आयशा को? Yes. Now listen very carefully. Why is this statement very important? Why is this equation very important? So we have, let us suppose that you have been given a container. This container, it contains two liquids. It has two liquids. Blue liquid okay, and red liquid. That means there is liquid A, there is liquid B. Now, if you have to get the concentration of this solution, You have not made the solution. You have been just given the solution and you have been asked to get the concentration of the solution. Now it becomes very difficult because you don't have a certain measuring tool which can measure the concentration of any solution. Okay. So now what you can do, you can apply the Raoult's law. How you will apply the Raoult's law? You will know that this container, if it is, you will seal the container and then there will be some vapors that will be due to blue particles. There will be some vapors that due to red particles. Okay. अब यहाँ पे क्या कीजिए आप? You apply and you put up a barometer or a manometer, and this will give you what? The total pressure that is there, the total vapor pressure. So it will get you, you will measure what? You will measure the P total. You will measure the P total. Okay. Now, once you have measured the P total, you have got the LHS. You have got the LHS. Now, what is remaining? The P0 A, P0 B, and P0 A again. So P0 A and P0 B, these all will be there in the data booklet, right? So it is not the first time you are measuring it. So the vapor pressure of pure water or vapor pressure of any liquid, it is already maintained in the data booklet because it is a constant. All of these things are what? Constant. They don't change until unless you change the temperature. So for the room temperature or for any particular temperature, all of these vapor pressure of pure liquids, they have been defined already, and you will get this easily on data booklets. Now this equation is very easy linear equation in one variable where you have to just solve for the chi b here. You just need to solve for chi b and then you will get the answer. And now what is the concentration of this solution? If you see here, we just need a manometer in order to measure the P total, and we need this data booklet. And so this data booklet is now cheaply available. If you just Google the term, the vapor pressure of pure liquid, that is water or something else, you will get the answer. What is the P0 A and P0 B is. So this is why it is very important. This P total, it should be measured. Okay. This is always measured because we have a tool which can easily measure it. Now, but you will get some questions which are very important and in which you have been asked to calculate P total. That is completely rubbish. It is like आपको volume दे दिया है, and they are asking you to calculate the length of the cube. So we all know there is a formula that if I just cube root the volume, then you will get the length. But practically speaking, it is a very redundant and a very bad question because if you have a cube, then you will take a scale and measure the length, है ना? आप ये सोचिए कि कोई क्यूब रूट करने बैठ गया है और कोई जाके स्केल लेके जाके बस लेंथ मेजर करके आ गया क्यूब का. So who is the smarter one? The one who took the tool that is the scale and he measured it, right? So generally what happens when you can measure something, you will measure it. Calculation तभी यूज करते हैं जहां पे आपको क्या करना हो, जहां पे you can't measure, you don't have any tools to measure. So P total should always be measured. And if there is any question जहां पे आपको पूछ रहा है कि P total निकालो कैलकुलेट करके, it may be an important question जो बोर्ड में बहुत बार पूछा गया, एक सवाल है ऐसा, but it is a bad question always. So it is a bad question. Important thing is that you calculate the concentration of the solution that is given. Now, all of you understood the importance and how to look at this particular formula, yes or no? Please tell me.
Yes, sir.
Yes, sir.
है ना? So
Yes,
this part, that P total part is measured and this part is calculated. ठीक है? और इसी बात को जो है हम कल, I will use this same statement tomorrow. ठीक है? So this portion is calculated. है ना? This portion is calculated and this portion P total वाला क्या है? उसको measure किया जाता है. ठीक है? So don't write these things measured and calculated. इसको दिमाग में रखिए बस. And I think you have completed. है ना? आप लोगों ने लिख लिया सारा? You have completed ना writing this down. Yes or no?
Yes, sir.
Yes, no?
Yes.
Okay, thank you. ठीक है. Now let us understand the graph for Raoult's law. And again, don't write, just write the topic with me. Graph, write the topic with me for Raoult's law. अच्छा, निदा आपको समझ में आया?
हाँ.
Okay. Graph for Raoult's law. Okay. Now, graph for Raoult's law. Please don't draw anything here. Please don't draw anything here. Just listen. In the y-axis, we will be plotting for the pressure. No, we will be plotting for the pressure. And in the x-axis, here I will be writing chi b. That means the mole fraction of B will be in this way, है ना, on the x-axis. अच्छा ये बताइए, at this point, what will be the value for chi b?
0.
0. Chi b is equal to 0. That means there is no solute in the solvent. Yes or no?
Yes.
And if there is no solute, you have only solvent, then chi a will be equal to how much?
1.
1. That means what do you have? You have pure solvent, yes or no? Please tell me, all of you. You have
Yes.
pure A. And we all know the vapor pressure of pure A, it will be equal to P naught A, yes or no? Please tell me. Correct?
Yes,
Hai? Okay, that means in the y-axis, sorry, in the z-axis we have, sorry, in the x-axis we have 0. In the y-axis, let us put up a point here. Let us say that this point is the point that is representing the P naught of A. All of you clear, yes or no? Please tell me. Any
Yes,
doubt
sir.
with anyone? Nida, Mansi, Kulsum, Hiba, Hamza, Hiba?
No, sir.
No doubt,
No.
ना? Okay, fine. Now, अब chi b जो है 0 से लेके 100 तक तो जाएगा नहीं. What can be the maximum value for chi b? Tell me. Chi b का maximum value क्या होगा?
1.
1, right? Because it is mole fraction, and mole fraction cannot be more than 1. Cannot be more than 1. Okay. Now at this point, okay, second. So I can write that this point here. At this point, chi b will be equal to 1 and chi a will be equal to 0. And if I make a line starting from here, is this straight? I don't know. Now, then what I will say, let us suppose that B here, the component B, it has more vapor pressure. That means it is more easily evaporating and it has less intermolecular forces of attraction. If the particles of B, they have less intermolecular force of attraction, then they will be evaporating more easily. If they are evaporating more easily, they will be forming more vapors. If they are forming more vapors, the vapor pressure will be higher. So we are just assuming one thing, that for pure B, the vapor pressure will be higher than A. So this will be P naught B. So this is an assumption that we are taking in order to make the graph. कुछ तो लेना था assumption. या तो PA ज्यादा होता, या तो PB ज्यादा होता, या तो दोनों बराबर होते. अब इसमें क्या लेके चलते हैं? जनरली बुक्स में भी यही लेके चलते हैं. Assuming component B is more volatile than A. है ना? It means B forms vapors more easily. है ना? B forms vapors more easily than A. अच्छा, now we have got all of these 2 points. है ना? ये दोनों point मिला है हमको. Now what I want your focus is, I want all of your focus on this point once again, where chi b is equal to 0. Okay, where chi b is equal to 0. If chi b is equal to 0, then there is no B. If B is not present, then the pressure due to B will also be equal to 0. Yes or no? Please tell me. The pressure due to B will be equal to 0. Correct?
Yes, sir.
है ना?
Yes.
Now, slowly when I move forward in the x direction, what is going to happen? I will start from here, that is 0, and slowly, the pressure due to B will also increase, and at the point where we have only B in the solution, that is, then the pressure will be equal to P naught B. So this is the graph that you will be getting for the pressure due to B in the solution. Yes or no? Please tell me. All of you understood this plot?
sir.
Yes or no?
Yes.
So this red line is giving me PB. Now, similarly, I will start from here only, that is P naught A. Now, at this point of time, at this point here, the solution, it only has A, and slowly what is happening? The chi A is decreasing from 1 to 0. So slowly the pressure due to A will also tend to decrease, and it will get to 0, where chi A is equal to 0. So when chi A is equal to 0, the pressure due to A will also be equal to 0. And we will say that this is giving me the plot for P of A, the pressure due to A. And then you have this plot. So if you add both of these plots, then you will get a line like this from here to here. So initially the total pressure is equal to what? The total pressure, it is equal to the pressure that is due to only A, है ना? यहाँ पे क्या है? सिर्फ और सिर्फ A है. Initially you have the total pressure, it is also equal to A, है ना? That it is also equal to P naught A. Slowly what is happening? You are adding P naught B, and P naught B is more volatile. If it is more volatile, P naught B will be increasing the total pressure, and increasing karte it will take it till P naught B. So this black line here, it is representing what? It is representing P total, which is equal to P of A, the pressure due to A, plus the pressure due to P. Okay, so is the graph clear with everyone? Yes or no? Please tell me.
Sir, can you explain once more why we assume that B is more volatile than A?
No, नहीं, ये बस हम assume कर रहे हैं, ठीक है? उसका उल्टा भी assume कर सकते हैं. बस ग्राफ में ये होगा कि P नॉट, ये P नॉट A ऊपर आ जाएगा और P नॉट B नीचे रहेगा, कुछ उसमें फर्क नहीं पड़ने वाला. ठीक है आतिफ? ओके, एक केस लेके चल रहे हैं हम लोग, ये समझ लीजिए, ठीक है ना? We are taking a case where you have B is more volatile than A. अभी तो A और B कुछ नहीं है ना, अब इसको स्वैप भी कर सकते हैं आप, राइट? किसी का तो ज्यादा होगा किसी से. चलिए, प्लीज ड्रॉ द ग्राफ, ड्रॉ द प्लॉट, and while you are drawing, please try to understand each and every. There are 3 lines here, है ना? There are 3 lines and there are 2 points. Okay, so you have to understand the importance of all of these things. There are 3 lines: the red line, the blue line, and the black line. And there are 2 points: the blue point and the red point. सबका इंपॉर्टेंस आपको बता रहना चाहिए कि यहाँ पे क्या है, वहां पे क्या है. And let me know if you have any doubt, है ना? We can talk about it. Also raise your hand when you're done.
Sir, will the length of the black line give us P total?
No, 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 no. Length नहीं देगा.
It's just there to represent it, right?
Listen, देखिए, अगर आपका if you have the small, यहाँ पे आपके पास small fraction क्या होगा? Let us suppose chi b is equal to 0 था, यहाँ पे chi b कितना हो जाएगा? 0.1 हो जाएगा, and chi a will be equal to 0.9. ठीक है?
Yes, sir.
Okay, इतना समझ में आ रहा है? At this point of time ये P total होगा, यहाँ पे इतना होगा. This will be the P total. Okay,
Yes, sir.
got it?
Yes, sir.
Okay, raise your hand when you're done. Okay, okay, so all of you are done. आतिफ, लिख लिया आपने? आतिफ हो गया? अरे आतिफ, आर यू देयर? नहीं है क्या? ये आतिफ भी है जिनका डिस्कनेक्ट होते रहता है. Okay, so we'll write a question now. निदा एंड मानसी, समझ में आया ना आप लोग को ग्राफ?
हाँ.
Please write this question. So see, this question has been asked many times, है ना? 9, 10, 12. But still, it is a bad question. It is an important question, but it is a bad question. I mean, ये फर्स्ट वाला तो खराब है, सॉरी, ये फर्स्ट वाला तो खराब है, सेकंड वाला अच्छा सवाल है, ठीक है? यहाँ पे एक करेक्शन है, मोल फ्रैक्शन ऑफ ईच कंपोनेंट इन वेपर फेज लिखिएगा. It's very, very important. Okay. All of you are done writing the question, yes or no? लिख लिया सबने?
No, sir.
No, sir.
नहीं, लिखिए. हाँ, ठीक है. All of you are done ना? All of you are
Yes,
done?
sir.
Yes, sir.
Okay, ठीक है. Let us look at this question. It is a easy question, okay? भले ही बड़ा हो लेकिन बहुत ही आसान सवाल है, ठीक है? There are a few things that is already given to us. Vapor pressure of chloroform and dichloromethane at 298 Kelvin is 200 mmHg and 415 mmHg. That means they have given us the vapor pressure of pure chloroform and pure dichloromethane. So pure chloroform, P naught of CHCl3, they have given us as 200 mm of Hg. Okay? And then next thing is 415, that is for P naught of CH2Cl2, it is given as how much? 415 mm of Hg. So this is the one of the information that they have given. The other information that they have given is 25.5 gram of CHCl3 and 40 grams of CH2Cl2. They are mixed, right? They are mixed. So what are we mixing? We are mixing 25.5 grams of CHCl3 and 40 grams of CH2Cl2. 40 grams of CH2Cl2. Okay. Now, from this information, we can get the number of moles of CHCl3, which will be equal to the given mass divided by molar mass of CHCl3. Similarly, we can get the number of moles of CH2Cl2. Kaise? This will be also the same thing, given mass divided by molar mass. So what is the given mass for CHCl3? Tell me, guys. What is the given mass for CHCl3?
25.5.
25.5 gram.
Okay, 25.5 grams. The molar mass will be equal to how much? So chlorine is 35.5. Okay, chlorine is 35.5. सो 35.5 यानी कि आपका 30 30 30 90 5 5 5 15 15 और 0.5 विल बी इक्वल टू 1.5, ये हो जाएगा आपका 16, है ना। सो इट इज 90 प्लस 16.5, ये आपका कितना हो जाएगा 106.5 ना 106.5। देन यू हैव कार्बन एंड हाइड्रोजन 13, कार्बन इज 12, 1 हाइड्रोजन 13, कितना हो गया आपका 0.591, so 119.5, 119.5 grams per mole. Okay, now you will calculate this term and then number of moles of CH2Cl2, ये कितना हो जाएगा, given mass is 40 grams, divide by, now again Cl2 will be equal to how much, 35.5 35.5 70 70 70 71 71 हो गया, और कार्बन का 12 और 14, so this will be 4 1 5 8 85, it is 85 grams per mole. Okay, now you can cancel the grams and grams, calculate the number of moles for each of these components. ठीक है, calculate for each of them. Send the answer in chat, okay? Number of moles of CHCl3 and number of moles of CH2Cl2. Send the answer guys, क्या हुआ, number of moles निकालना ना। Yes, Kulsum, correct. Waiting for others also. Saksha correct, Nida correct. Who sent me answer earlier? Hamza correct. Yes, Krishna correct. So all of you must be getting the for the second one 0.47. ठीक है, मोल्स होगा, प्लीज ऑल्सो राइट द यूनिट्स, एंड दिस विल बी इक्वल टू 0.21 मोल. ओके, now from these values you can easily calculate the mole fraction of CHCl3, which will be equal to 0.21 divided by 0.21 plus 0.47. ठीक है, चलिए कैलकुलेट कीजिए इसको. 0.21 अपॉन 7 1 8 4 2 6. ठीक है, तो 0.21 अपॉन 0.68 इसके बराबर आ जाएगा 21 अपॉन 68. अब आप लोग कैलकुलेट कर लीजिए 21 अपॉन 68. नहीं कृष्णा, मोल फ्रैक्शन कभी भी आपका 1 से ज्यादा नहीं आएगा ना कृष्णा. देखिए कुछ गलती कर रहे हैं आप. यस निदा करेक्ट, कुलसुम करेक्ट, ये अक्षय करेक्ट, हमजा करेक्ट. कृष्णा आप देखिए फिर से, दिस विल बी इक्वल टू 0. आई मीन कृष्णा आपका थोड़ा सा फिर से ये हो गया 0. दिस विल बी 308. ठीक है, 0.32 तो नहीं होगा फॉर श्योर. 308. So what will be the mole fraction of CH2Cl2? कितना हो जाएगा ये? 1 minus the mole fraction of CHCl3. This will be equal to 1 minus 0.308. अगर हम 308 को लेके चले तो this will be equal to 0.692. ठीक है, दोनों मोल फ्रैक्शन मिल गया हम लोगों को ना, दोनों मोल फ्रैक्शन मिल गया हम लोगों को. Now what we need to do, we need to just calculate the P total. So P total will be equal to pressure due to A plus the pressure vapor pressure due to B. Okay, pressure due to A, it is equal to P naught A chi A. This is equal to P naught B chi B. P naught A chi A, this is equal to how much? It is equal to P naught A. P naught A कितना था? 200 ना. So this is equal to 200 into chi A is this one. 0.308 ले लेते हैं, 0.308 plus P naught B will be equal to 415 दिया था उसमें. 415 multiplied by 0.692. So whatever you get, the answer will be in terms of mm of mmHg. The answer will be in terms of mmHg. अब देखिए 200 into 308, so 100 into 2 into 308, so 100 into 308.308 will be equal to 30. 30.8 into 2 will be equal to 60 और 16 61.6. अब इसको कैलकुलेट कीजिए 415.0.692. I think Kulsum, you're right. This is 287.18 mmHg. Okay. So just before adding, let me also tell you one more thing here that P total भी आपका सही है, I hope so. So this is for the pressure of CHCl3 and this is the pressure due to CH2Cl2. So Akshay and Kulsum, both of you are getting the same answer. So I think this is right. 348.78 mm Hg. Okay, so this is the P total. This is the P total that we have got. लेकिन क्या ही फायदा इतना कैलकुलेट करके, माइनोमीटर बैरोमीटर लगा देते, सवाल करने वाले तो आपको आंसर मिल जाता पहले ही. Fair. So the first part is done. Let us move on to the second part. In the second part, what they are asking the mole fraction of each component in vapor phase. In vapor phase, that means if I take some, yeah, इसको ले लेते हैं. So let us suppose if this is my container and all, है ना, यहाँ पे आपके पास क्लोरोफॉर्म और क्या है, डाइक्लोरोमीथेन है. So what they are asking, they are more interested in which part of this. So we have already calculated the chi A and chi B. Okay, but they are not interested here. Where are they interested? They are interested in this portion. They are more interested in this portion now. Okay, so in this portion, so since we have already used the term that is chi A and chi B, what we will say that the mole fraction for this here will be YA and YB. Okay, YA and YB. Is that clear? Yes or no? YA YB क्यों use करें? Because chi A chi B पहले use कर चुके हैं हम लोग. Now, according to Dalton's law of partial pressure, according to Dalton's law of partial pressure of any component A, it is equal to, in a mixture of gases, है ना? In a mixture of gases, partial pressure of any one gas is equal to the total pressure multiplied by its mole fraction. So in this case, this is the Dalton's law for partial pressure. Now in this case, what we'll write, Y of CHCl3, or rather I should say like this, that the pressure of, that means the partial pressure of CHCl3 will be equal to the P total into, I'm writing Y of CHCl3, है ना, mole fraction of CHCl3. So Y of CHCl3 ये calculate करना हमको. CHCl3 will be equal to what? The partial pressure due to CHCl3 divided by the P total. और अभी just हम लोगों ने calculate क्या किया है? What is the partial pressure for CHCl3? It is equal to 61.6. So this will be equal to 61.6 divided by the P total is equal to how much? 348.78. 348.78. Now this is also in mm of Hg. This is also in mm of Hg. And that is why both of these things can be cancelled. And you will obviously get the mole fraction as a unitless quantity. So please calculate the value here. And after you have calculated the value, you will write Y of CH2Cl2 will be equal to 1 minus Y of CHCl3. Okay, and then you will get the answer for CH2Cl2. But first of all, please calculate this. 61.6. इसको देखिए, decimals हटा दिया कीजिए. So you will get 61. Sorry, not 61. You will get 6160. 100 से मल्टीप्लाई कर दिया आपने ऊपर, 100 से नीचे मल्टीप्लाई कर दीजिए 348. अच्छा, इससे अच्छा क्या कीजिए आप इसको, सॉरी, कैलकुलेट दीज वैल्यूज 62/350. ठीक है, इसको कैलकुलेट कीजिए, आसानी से हो जाएगा. आई थिंक यू विल गेट अ सिमिलर टाइप ऑफ आंसर. Yes, correct. This is equal to 0.17. Huh? Now, y of CH2Cl2 will be equal to 1 minus 0.17, which will give me 0. अच्छा, if you see now, it will be 0.77 करके होगा, तो approximate करेंगे तो 0.18 ही आना चाहिए, ठीक है? It will be 0.18. We approximated, it will be 0.18, so this will be equal to 0.82. Okay. Now again, I'm asking those who have not understood this part, that is the according to Dalton's law of partial pressure, please let me know now. So 0.18 and 0.82 is the mole fraction of vapor phase, ठीक है? As you can see very obviously that CH2Cl2 is what? It has more content or more contribution in the vapor phase because it is more volatile. है ना? The P0 is equal to how much? 415. ठीक है? The P0 is equal to 450. That is why it is very much available in the vapor phase. काफी easily it is getting evaporated. Then all of you, yes or no, please tell me.
Yes, sir.
Yes, sir.
Let me see if I can give you more. So write this question, a very similar question, okay? Write this question. At 298 Kelvin, the vapor pressure of pure benzene is 0.246256 bar. Vapor pressure of pure toluene is equal to 0.0925 bar. है ना? So the P0 for benzene and toluene is given. Now they have also given the mole fraction of benzene in the solution. If you have been given the mole fraction of one of the component, you can easily find the mole fraction of the other component by using chi A plus chi B is equal to 1. Then they have asked you to calculate the total vapor pressure. Again, bad question because total vapor pressure will be equal to P0 A, that is given, P0 into chi A given, P0 B given, chi B is also given. Once you have calculated the chi B, calculate the composition and the vapor phase in terms of mole fraction. Again, using the Dalton's law of partial pressure, you can calculate this. Okay, so please try to do this and tell me what is the total vapor pressure. वो बताइएगा आप. Okay, and after that you calculate the composition of the vapor in terms of mole fraction. यानी कि vapor phase में कितना benzene होगा और vapor phase में कितना toluene होगा. चलिए, please write this down. Let me know when you're done. Send the answers in chat. Okay. Also, let me know if you need any help somewhere while doing the question. If you need any help, just let me know.
So benzene is the solute, right?
नहीं, कुछ आप ले सकते हैं यहाँ पे, कुछ कोई दिक्कत नहीं है, ठीक है. इट विल नॉट बी एन इशू. हम तो यही बोलेंगे जो पहले दिया हुआ उसको का ए ले लीजिए, ठीक है, उसी को ए ले लीजिए, जो बाद में दिया उसको बी ले लीजिए, उसमें आपको कोई मार्क्स काटेगा नहीं. ऑल्सो ए और बी तो हमारा कन्वेंशन है ना आतिफ, है ना? ये सुनो आतिफ,
Yes.
है ना? टोटल वेपर प्रेशर, अच्छा नो कृष्णा। हाँ निदा, यू आर राइट। कृष्णा प्लीज ट्राई अगेन। नो आतिफ, नो 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 आतिफ। What is the mole fraction? Tell me for each of them, all of you first of all. मोल फ्रैक्शन क्या है दोनों के सबके लिए, बेंजीन और टॉलुइन का? ये अक्षय और राइट। आतिफ एंड कृष्णा मोल फ्रैक्शन बताइए आप लोग। कृष्णा वाई 0.59? नहीं नहीं कृष्णा, कैन यू प्लीज सेंड द माइक ऑन?
So by mistake I did 0.59. I mean, I entered
अभी
9.
नहीं 0.5 भी नहीं होगा। 0.5 क्यों होगा बताइए? हाँ कृष्णा।
Oh yes, sir. It's
ठीक है, फिर मल्टीप्लिकेशन में भी कुछ आप गलती कर रहे हैं। ओके वेट अ सेकंड। हमजा, व्हाट इज दिस एन बेंजीन? हमजा
Sir, by mistake I wrote that, and it was
वो
mole
है
fraction.
क्या? अरे मोल फ्रैक्शन तो बेंजीन का दिया हुआ है भाई, आप लोग क्या कर रहे हैं यहाँ पे? रीड द सेकंड लाइन आफ्टर 0.0925 बार, व्हाट इज द रीजन? इफ द मोल फ्रैक्शन ऑफ बेंजीन, अच्छा ये एक सेकंड, ये वेपर फेज का है क्या हमजा? वेट अ सेकंड, सॉरी हमजा, ये वेपर फेज का है क्या? वेपर फेज का इतना हो सकता है हमजा, हेलो।
Yes, sir.
अरे पी टोटल तो पहले बताइए, सीधा आप वेपर फेज बताने लगे। टोटल प्रेशर कितना आया?
So I was calculating that.
है व्हाट? ये क्या है नंबर ऑफ मोल्स? अरे बेवकूफो, आप लोग से मार खा जाइएगा, आप लोग तो जवाब भी नहीं देते सही से।
Sir, I wrote that by mistake, that N benzene there.
एन एन छोड़िए, वो 0.698 क्या है वो बताइए आप हमको ना, वो तो हम समझ रहे हैं, बेंजीन आप छोड़ दीजिए, आप बताइए तो वो क्या है?
Sir,
0.698
mole
क्या है
fraction of benzene vapor.
इन वेपर फेज?
Yes, sir.
ठीक है, अब ये बताइए पी टोटल कितना है? हाँ अच्छा, समझे हम, बहुत बढ़िया। आपने क्या किया है यहाँ पे? कैलकुलेट द कंपोजिशन ऑफ मोल फ्रैक्शन, आपने बस इन दोनों को मल्टीप्लाई कर दिया ना? हाँ यही क्या लगता है आपने? नहीं ये भी तो नहीं किया होगा, ये करने से तो ज्यादा आना चाहिए आंसर। हमजा कैन यू प्लीज
Sir,
सेंड द
I
माइक ऑन?
divided.
व्हाई, क्यों भाई? अरे सोल्यूशन है ना, ये तो प्योर है। प्योर और सोल्यूशन में तो फर्क होगा ना। अभी तो सवाल किया हमने, सेम ही तो सवाल है जो पहले किया था। इसमें तो पी ऑफ सी एस सी एल थ्री ना, पी नॉट तो नहीं लिखा है यहाँ पे हमजा? पी नॉट लिखा है क्या यहाँ पे? नहीं ना। पार्शियल प्रेशर, पार्शियल प्रेशर। समझ में आ रही बात हाँ या ना? कुछ तो बोलिए, नहीं समझ में आ रहा तो फिर से हम
Yes, sir.
एक्सप्लेन करें। ठीक है, पहले आपको टोटल वेपर प्रेशर कैलकुलेट करना है। देखिए पी टोटल कैलकुलेट कीजिएगा, it will tell you pressure due to benzene, okay, plus the partial pressure of toluene. This will be giving you P naught of benzene into the mole fraction of benzene plus the P naught of toluene जो कि दिया हुआ है आपको into the mole fraction of toluene. ठीक है, so ये जो आपकी क्वांटिटी आएगी और ये जो क्वांटिटी आएगी ना, so these will be the partial pressures of benzene and toluene. Now that partial pressure you have to use and you can calculate the Y of benzene, that means the vapor phase में क्या होगा benzene का, this will be equal to the pressure due to benzene है ना, partial pressure not pure, सिर्फ partial pressure यानी कि ये वाला quantity इन दोनों को multiply करने के बाद जो आएगा divide by the P total. ये P total कहाँ से आएगा, this P total is this P total here. चलिए कैलकुलेट कीजिए इसको। कुलसुम आपने तो पहले ही आंसर दिया था ना शायद, आपका तो सही है, दैट इज फाइन। हाँ निदा करेक्ट, करेक्ट निदा, y of benzene is correct. So अभी तक अच्छा अक्षय correct correct correct, y of benzene is correct Akshay. Okay, who else has given me some answer? Krishna, now it is correct, total vapor pressure is correct. Yes, toluene के लिए भी ठीक है, correct for toluene also Nida. Mansi is getting disconnected बार बार। P naught of benzene is 0.256 into 0.4 plus P naught of toluene is equal to 0.0925 into मोल फ्रैक्शन ऑफ toluene will be, ये 0.4 है तो ये 0.6 हो जाएगा। अब इसको मल्टीप्लाई कीजिए आप, सिंगल डिजिट है, आराम से हो जाना चाहिए। 424 20 ना, 4 दूनी 8 9 10, it will be 1.024 प्लस 6 25 30, 6 दूनी 12, 12 3 15, then what do you have, 9 6 92, 92 और 1 93, 52 52 53 होगा। हाँ हमजा, now it is correct. तो ये आपको कितना आ रहा है, 1.024 प्लस 0.5 0.0550 होगा क्या, 0.0550 होगा। तो 1.079, oh sorry, I have done one mistake here, no, चार डिजिट में यहाँ पे कितना हो जाएगा, 0.1579, इसको ले सकते हैं आप 0.158 बार। अब y of benzene will be equal to 0.1024, टोटल कितना है 0.158, now it is fine, I think 0.648 आ रहा है ना, और y of toluene कितना आ जाएगा? y of toluene will be 1 minus 0.648. So this will be equal to 6 और 3, 4 और 5, 8, 2, 10, 0.352 ना? I hope so. चलिए, हाँ कृष्णा, नाउ इट इज करेक्ट. ठीक है. चलिए, सो आई थिंक ऑल ऑफ यू आर डन. किसी को डाउट है इस सवाल में तो प्लीज बताइए. Those who are having any doubt in this question, please tell me. No one?
Sir, can we use the other formula for this question? P naught A plus P naught B minus P naught A into chi B.
Which formula?
The other one we did it using only chi B.
You can use that also. You can use that also. लेकिन उसमें देखिए एक दिक्कत ये होगी ना. See, actually the thing is that we need these values, है ना? यहाँ पे substitute करने के लिए, correct है?
Yes, sir.
Right. So वो आपका नहीं आएगा वहाँ पे. आप बोल रहे हैं कि P total आप कैसे कैलकुलेट कीजिएगा? P total will be equal to it is something like this ना, P naught of A plus P naught of B minus P naught of A into chi B. Yes, right? Yes or no?
Yes, sir.
है ना? इसमें आप ये देखिए, ये वैल्यूज नहीं आएंगी ना, 1.024 और 0.550, जो कि आपका क्या है? दिस इज द प्रेशर ड्यू टू बेंजीन एंड दिस इज द प्रेशर ड्यू टू टोलुइन. यस,
Yes, sir.
ठीक है. और दूसरी चीज हमने क्या कहा था, इस इक्वेशन को हम लोग कब यूज करेंगे? जब क्या निकालना हो, व्हेन वी हैव टू कैलकुलेट द chi b. If you have to calculate the chi b, then you will use this formula because यहाँ पर P total आपको दिया हुआ रहना चाहिए. यहाँ पे तो हम लोग उल्टा करें ना, P total नहीं हम लोग क्या करें, कैलकुलेट करते हैं. Got it? आते yes or no?
Yes, sir.
Okay, fine. Okay, so that's it for today. One announcement is that tomorrow you guys will have test MCQ on portal. ये app जो भी यूज करते हैं आप. The topics will be solubility. ना solubility में क्या, solubility of एक तो solubility हो गया, and then solid in liquid, factors affecting the solubility of solid in liquid, then gas in liquid. उसके बाद हेनरीज लॉ, जो कि गैस के अंदर ही आता है. ठीक है, हेनरीज लॉ एंड वेपर प्रेशर. ठीक है, इज दैट क्लियर? यस और नो, प्लीज टेल मी
Yes,
द
sir.
टॉपिक्स.
Yes, sir.
है ना? ठीक है, ओके, चलो.